Okay, so the equation linking pressure difference, so if it's a difference it must be a change in pressure, that's a lowercase p, and I always remember it as rho, which of course is the density, times by g, which is g, times by delta h, which is the depth for 1 mile. Calculate the increase in pressure. So we're going to do the density, which is given in the question, G, which is 10, which is given on the front of the exam paper, and the depth is 700 meters. And if we work that out on a calculator, we get 7,196,000 pascals. You could argue that we've given it to too many significant figures, because G is only given to 2 significant figures, so possibly you could argue that this should have been rounded up to that, although that's not tested in this question, so either of those answers is okay. Atmospheric pressure they've given in standard form. Now 1 times 10 to the 5, hopefully, well, if you're not sure you can always put it into your calculator, okay, but hopefully you'll know that that's 100,000, and the idea is that the decimal point that you saw there goes 1, 2, 3, 4, 5 places to the right to get it into a normal format. If we've got the pressure from the 500 meters of water, then if there's pressure from the surface as well, then those two pressures are just going to get added together. So if you add 100,000 to this, you get 7,296,000 pascals. The equation that links pressure, force and area, P, no, that's a lowercase p, an uppercase F and an uppercase A. If we're going to calculate the force on the outside of the door, there's 2 ways that you can do this. You know what the pressure is, you're trying to find the force and you're given the area. You can either substitute and then rearrange, or you can rearrange first, which I'm going to do here, and then do the substitution into it. And again, that's given in standard form. If you want to turn it into you're going to need 5 zeros on there. Okay, times by 3.1 gets us a grand total of 12,710,000. Again, you could argue that that's only to 2 significant figures and that's only to 2 significant figures, so actually the answer should be 13 million, but again, that's not tested, that's not a marking point in this question. And the last bit, why is the pressure less? Well, if you go back to the formula, rho GH, if this value here is decreases, and these two here are constant, then this value here must also decrease.